let's solve the following example in which we need to take the second and cross partial derivatives with respect to y, and also we need to verify the Young's theorem. In other words, we need zxx, zyy, and also we need to verify if zxy is equals to zyx, which is the Young's theorem. So let's start by first finding the first partial derivative with respect to x and then with respect to y. Remember that we need the first partials because then we will use them to obtain the second and the cross partial derivatives. Notice that in this case we have two factors which are products. Therefore, we can use the product rule. And remember that this is the derivative of the first term times the second factor plus the first factor times the derivative of the second factor. And this is with respect to x. So let's start. Internally, the constant part is 2 times the derivative of x with respect to x is 1 plus, here the constant part is 3y times the derivative of x with respect to x is 1 here the derivative of 3x with respect to x is simply 3 plus the derivative of a constant is 0. This means that zx is equals to 2 plus 3y times 3x plus 1 plus 2x plus 3xy times 3. Then we proceed with the algebraic operations. So this is 6x plus 2 plus 9xy plus 3y plus 3 times 2x is 6x plus 3 times 3 is 9xy. So the first partial derivative with respect to x is 9xy plus 9xy is 18xy plus 12x plus 3y plus 2. Now let's repeat the same procedure, so the product rule with respect to y. And you will notice something interesting. So let's write it. Remember that the product rule is the same in terms of the rule itself. However, here we need to remember that it's going to be with respect to y. So zy is equals. Now, the derivative of 2x with respect to y is 0 because there is no y, plus, here the constant part is 3x, times the derivative of y with respect to y is 1 times the second factor plus the first factor times. Now notice that the derivative of 3x with respect to y is 0 because there is no y, and 1 is a constant, so the derivative is also 0. So you will notice that actually this operation with respect to y is simpler. Here is 0 plus 3x is 3x times 3x plus 1. Now 0 plus 0 is 0. 0 times all this factor is going to be 0. So this is plus 0. This means that the partial derivative with respect to y is simply 9x squared plus 3x. Now that we have our first partial derivatives, we can proceed and find our second order partial derivatives. So here we're going to take again with respect to x. The constant part is 18y times the derivative of x with respect to x is 1 plus 12 times the derivative of x is 1 plus, because here we don't have any x variable, so this is 0 plus 0. So the derivative, the second partial derivative with respect to x is simply 18y plus 12. Now let's proceed with the derivative of this operation with respect to y. In other words, the second partial derivative with respect to y. Notice that in this case, the derivative of 9x squared with respect to y is 0 because there is no y, plus the derivative of 3x with respect to y is also 0. So this means that the second partial derivative with respect to y is 0. Now let's continue with the cross partials. Because we already took the derivative with respect to x, now we need to take the derivative with respect to y. In the case of the first term, the constant part is 18x times the derivative of y with respect to y is 1 plus. In the second term, there is no x, so it's 0, plus here we have the constant part is 3 times the derivative of y with respect to y is 1 plus 2, which is a constant, so the derivative is 0. So this means that the cross partial derivative is equals to 18x plus 3. And now let's find the cross partial derivative in which first we already took the derivative with respect to y. So now we need to take the derivative with respect to x. So here the derivative of 9x squared is simply 18x plus the derivative of 3x with respect to x is 3. And as you can see here, according to the Young's theorem, the cross partial derivative will be the same no matter the order in which you take the derivative. So if you first take the derivative with respect to x and then y, will be the same as taking the derivative with respect to y and then with respect to x. In that sense, we verified de Jong's theorem.